Hello, my name is Ram Meher and today I am giving a demo lecture on Newton's laws of motion. So as this is my demo lecture, I try to keep it only related to the theoretical concept of the topic. So in today's lecture, we are going to see today's lecture in four parts. Firstly, we are going to see some introduction and prerequisite for the topic. After that, Newton's first law, then second law, and after that we try to work some around that first and second law. And finally, we are going to see a Newton's third law with the concept of tension. So to understand this topic, you should have good understanding of the topic of kinematics. So kinematics is basically studies of bodies in a motion. So while studying a kinematics, you might have heard terms like a initial velocity u, final velocity v, acceleration of a body having mass m. Okay, and there are various formulas for that. So kinematics gives you a motion, correct? And see, if we consider this motion as an effect of something, to be precisely effect of some cause. So which is that cause? Then there should be naturally some cause to produce some effect. Okay, so to produce a motion in a particular body, we need some cause, and that cause is force, right? Imagine a particular mass is at rest. If I have to put it that mass in motion, I have to apply some force on it. Or imagine other scenario, if some mass is in motion, I have to bring it to the state of rest. Also, I have to exert some force on it. So basically, force is a cause which gives you effect either motion or a state of rest, right? So the first part is motion is covered under the kinematics, and the second part, which is cause, which is given by Newton's laws of motion. We are going to see that Newton's laws of motion mainly deals with a force acting on a body, right? So naturally, there are four kinds of forces. As their name suggests, their types. Okay. Firstly, there is a contact force, which basically means that the force between body which are in a contact, right? And under that, there is a tension force, tension in a string, in a chain, in a spring. After that, normal force is that force when a particular subject or mass placed on a some ground, some table, there is a natural force of normal which is acting perpendicular upward on the mass. After that, friction is very important. It's the friction that gives your vehicle a speed. There is a friction between your tire and road, that's why you are gaining a speed, you are applying a brake, and your vehicle comes into the rest. Okay, next, non-contact forces. So as its name suggests, these are forces when two bodies are not in a contact. So there is a gravitational force, there is electrostatic force, and a magnetic force. So naturally, there is a no contact of two bodies when there is a gravitational force, electrostatic force, and magnetic force. After that, there is a weak force which is named as van der Waals. This part basically comes under the chemistry. In chemistry subject, you might have studied that. After that, nuclear forces, which is mutual force of attraction or repulsion in between proton electron or proton proton. Okay, so basically in Newton's laws, these forces we are going to see frequently. Okay, now Newton's first law. You might have heard the regular statement of the Newton's first law is that every body tries to continue a state of rest or motion unless and until external force applied to it. What does it mean? If a particular body is in a rest position, then it will try to continue its state unless and until external force is applied. Imagine a particular object placed on a table. Is it going to move itself? No. You have to apply some force on that. After that it will change its state of rest or state of motion, whatever it is. So if you look at the statement of the law, if the vector sum of all forces acting on a particle is zero, then and only then a particle remains unaccelerated. It's a very conceptual statement. If there are no forces acting on a body, then that body remains unaccelerated. So unaccelerated in two sense. Say if I am saying the acceleration of a body having mass is zero, it have two folds. Either it's a constant velocity, correct, or it don't have velocity at all. Yes, correct. If subject is at rest or is moving with a constant velocity, we can say that subject is unaccelerated. Now this word accelerated, you might have heard about the accelerator of your bike, your car. What is the function of accelerator in your car? When you apply the accelerator, the throttle increase the fuel supply to your engine produce a more energy, more power, and that power is transmitted to your vehicle tires, and tires revolves with a greater speed than usual. Then there is a force of friction between your tire and road, and which is acting against your motion. If the force of friction is acting in this direction, your motion is in this direction, right? So let's get back to the first law statement again. If a vector sum of all forces acting on a particle is zero, then particle remains unaccelerated. Now imagine this particular scenario of an elevator. There is a man standing in elevator with the lamp hanging in it. See, unfortunately, the rope of that elevator get detached and it will start falling downward with the acceleration 9.8 meter per second square, which is also acceleration due to gravity. Correct? Now, which is the direction of motion then? It's downward. Now, there are two point of views, a point of view of person A and person B. Let's take case of person A. What will person A think of this lamp? From his point of view, this lamp is unaccelerated. Correct? Right? After that, what does a person B will say? Person B will say this lamp is falling with the acceleration of 9.8 meter per second square. Yes, this is also correct. So naturally these two can't be correct at the same time. One of them should be wrong, definitely. So we consider this person B who is standing on a ground correct. According to him, what is the case? The lamp is falling with the acceleration of 9.8 meter per second square. Then why this person gets wrong? Why? So here comes the concept of inertial and non-inertial frame of reference. This person P, this observer, we call it as observer in inertial frame of reference. Then what is inertial frame of reference? It's a frame of reference in which all the Newton's laws are valid. So naturally non-inertial frame of reference means in which the Newton's laws are not valid. So in exams, if you might come across this concept, then there is a concept of pseudo force. What is pseudo force? As its name suggests, it's a pseudo, it's a fake, it's a false, but it's a force. To get a correct conclusion, you should apply a pseudo force on the object of reference. So to get both the observation correct, the man which is in non-inertial frame of reference should apply a pseudo force on the object of reference. Correct? Okay. So is Earth a frame of reference then? No. Earth strictly is not inertial frame of reference. Why it is so? If we take Earth as an inertial frame of reference, is it still? No. Is it not still? Earth is revolving around itself, also it's revolving around the sun. It's not in a static position. That's why we can't take strictly Earth as a inertial frame of reference. But we can take Earth as a good approximation of a inertial frame of reference. Because theoretically, if you calculate the angular velocity, angular speed of Earth, which comes very minute, something around 0, and therefore its acceleration also 0. So therefore we can approximate Earth as a good inertial frame of reference. Okay, get the concept? Now come to the second law. What is the second law? The acceleration of particle measured from inertial frame is given by the vector sum of all forces acting on particle divided by its mass. So let's formulate it mathematically. What does it say? The acceleration measured from inertial frame of reference. What does it give? It gives the acceleration, which is equal to the sum of all forces acting on a particle divided by its mass. Let's denote sum of all particle as F net and divide by its mass, which give a famous formula: force is equal to mass into acceleration. Okay, so acceleration and force are both are vector quantity. The direction in which you are applying a force, the acceleration in the same, you get the acceleration in same direction. But this is a special case of something, a general case. What is that general case? A rate of change of momentum is equal to the force applied. Again, let's see it mathematically. What is momentum? Momentum is denoted by P and given by mv, mass into velocity. Now what is rate of change of momentum then? Del P by del T. This is rate of change of momentum with respect to time, and is equal to the force applied, which is quite natural. If I am applying a force on a mass at a rest, it will change its momentum, which is given by mass of that object multiplied by its velocity by its changing. Right? Now, say there is a mass m and I am applying a force in this direction. So, the direction of its velocity will be in this direction. Okay, say it's have initial velocity u, and after applying a force it will have a final velocity v. In both the cases the mass is constant, correct? So again, m into final velocity minus m into initial velocity divided by del t, which is equal to force, Now take a mass constant, you will get v minus u divided by del t, which is a definition of acceleration. A rate of change of velocity is acceleration. So you get mass into that acceleration equal to force. See, this is a special case. Now, what is the general case of changing mass? Imagine a satellite carrying a certain amount of fuel. Okay, fuel has some mass. So at the time of its launching, it start burning its fuel. As time passes, it will goes up burning some fuels. At this position, the mass of fuel is m1, and at this position, at this height, the mass of fuel m2. So obviously m1 is greater than m2. So this is more general case of this. Understand? Now working around with the first and second law. So to work around, we have some example. So these are masses A, B, C, D, D is a disk, E and G. These are masses, and these pulleys are frictionless and massless. This D is a disk which rolls over with on this string. Now to work around with this law, there are few steps. In step 1, decide the system. Now, what is there to decide? When you are solving some problems, so while solving that problem, you should have some system, or you have to choose some system according to your problem. See, in problem, if you have to calculate a force or force or velocity of mass B, then you should build your system around this mass. Okay, after that identify the forces. Now naturally, if in a example, if you have to calculate a forces acting on this mass B, then you should be able to identify the forces acting on that B. After that, make a free body diagram. After identifying the forces, you should make a free body diagram of this mass. And in final step, choose the axis and write the equations. Now let's see various kinds of forces acting on mass C. This is ground, these are string. Okay. Now what are forces? The first force is a gravitational force which is given by mg. M is the mass of C. Second force is a normal force exerted by the ground on mass C. Okay. Now if I want to draw a free body diagram of C, and again there are two other forces at tension in a string. So there is T1 and T2. Whenever there is a string changes, a tension also changes. Okay. Now what is the free body diagram of mass C? Consider that mass with a dot and draw forces on acting on it. This is mg downward, this is normal upward, T1 and T2. Okay. Now if this mass is at rest, or if it is moving with a constant velocity, then we can say it's unaccelerated, and we can conclude that net of forces acting on it is 0. Correct. Now these are various forces acting on that mass, and if that mass is at rest, we can conclude that the net force acting on that body is 0. So how can we write? The summation of all force. So to decide which is positive and which is negative, we need to choose axis. So how to choose axis? Now if that person is applying a force in that direction, obviously all these blocks are moving towards this direction except D and E. D and E will move downward. Okay. So to consider all the masses in particular one system, all the masses should have uniform direction of velocity. Okay. So talking about C, there are 4 forces, and I have to choose axis. So one better idea to choose axis is that choose your x-axis in the direction of motion, or given. If the direction of motion is given, you should choose x-axis in that direction. Correct. So if I choose this is x-axis, positive x-axis, this will be a negative. This, and perpendicular to the x-axis there is a y-axis, This is positive y and this is negative y. So mathematically T2 minus T1 and n minus mg, the summation of all forces will be equal to 0, and you get the answer of forces acting on that body. Okay, now there are some suggestions to choose axis. The firstly, any three mutually perpendicular direction may be chosen as xyz axis provided they are coplanar. Okay, after that try to choosing x axis along the direction in which system is known to have or is likely to have acceleration. As I tell before, say if this man applying a force on this mass m in this direction, then naturally you can say that this mass will have velocity in this direction, correct? So while choosing axis for this mass, it's naturally to choose positive x-axis in this direction, and particular perpendicular to that x-axis should be your y-axis. Now in case of inclined plane, there might be a problem of masses on inclined plane, right? So imagine this mass which is on a plane which makes an angle of theta with the ground. So what about the forces acting on it? There is a gravitational force vertically downward mg. There is a normal force acting perpendicular to the surface, right? And if it is falling down, then this is the direction of motion. So in that case, you have to choose a positive x-axis in this direction, y-axis in this direction, this is perpendicular, this is negative x-axis, and this is negative y-axis. It will help you to solve problems more quickly. Okay, now let's get to the Newton's third law and the concept of tension. Now this is the pulley. Pulleys problems are very frequent in exam. So unless and until it is stated the mass of the pulley or anything related to pulley, consider pulley massless and frictionless. So now what is tension? A tension is a force which is produced in an object like thread, chain or spring. Now what is the direction of tension? If you have to find the direction of a tension, it is always away from the masses. If mass A, if object A having a mass, and it will produce a tension in this string, then the direction of that string, the direction of the tension produced in a string is like this. So this string is uniform here. So after this point, there is a change in a force or tension force. This is T2. Now T2 is basically produced by these two masses. This is, say this is M1 and this is M2. The tension force T3 is produced by mass D in vertically upward direction, and tension force T2 will produced by C and D in vertically upward direction. Okay, so the statement for Newton's third law is very famous. To every action there is equal and opposite reaction. And how this statement gives you the concept of tension? See, why tension is developing in this string. Say if this total system is in equilibrium. What do you mean by equilibrium? Equilibrium means a balanced condition. In this case, we can say if this system is in equilibrium, all bodies are in a state of rest, or more precisely we can say no body is moving. Okay, so If no body is moving, there is a state of balance. Now how to get that balance? So this mass produce a tension T1 in this string is balanced by a gravitational force mg, or it is to in reverse fashion. If the gravitational force on this mass is mg, then it will balance by the tension in the string, right? To every action there is equal and opposite reaction. So naturally we can conclude that T1 is equal to mg. To every action there is equal and opposite reaction. Why opposite? If we transpose T1 to this side, mg minus T1 will equal to 0, which might give same sense of your Newton's first law. What is Newton's first law then? If a body remains unaccelerated, we can conclude that net force acting on that body is equal to 0. So okay, this is all for my demo lecture. I hope you will like it. Thank you.